My name's Holly Bittinger. I'm a communications specialist at SentinelOne, and I'm here this evening to talk to you about using AI to thwart cloud ransomware. Really exciting stuff. And before we begin, I'm just curious, who here is already pretty familiar with SentinelOne? A few people? Okay. And let me ask this question. Who here has ever heard that agent-based solutions do not play well in the cloud? Has anyone heard that? Okay. You can be honest, a couple people. You might hear things like they're too siloed, they don't see the big picture, they're too difficult to deploy and manage, right? So I'm here today to dispel those myths, and I hope to persuade you by the end of this brief talk on why a cloud workload protection platform is your best last line of defense in a multi-layer cloud defense strategy. So let's talk about a commonly proposed solution for cloud security, and that is side scanning. This is a method of collecting workload data by collecting it directly from block storage, cross-correlating it with cloud metadata, and looking for vulnerabilities, leaked passwords, things like that, right? Seems like a pretty good idea, right? Kind of nice, maybe for peace of mind. Here's the problem, though. The battle with ransomware is won or lost in a matter of minutes, if not seconds. And these scans are typically performed daily, so these are not going to catch real-time incidents, nor are they going to do anything for behavioral process-level incidents. Now, you might say, well, we could do more scans, but more scans is more money, and this very quickly becomes pretty cost prohibitive. So you can see that this just really isn't a good solution for cloud security. Let's take a look at the timeline of a typical ransomware attack today. So our adversary finds keys or credentials maybe in clear text on GitHub, or maybe they manage to bypass multi-factor authentication. However they get in, they gain access, we have workload compromise. This is happening programmatically, so it happens in a matter of minutes, not hours or days, typically. The adversary quietly achieves persistence and begins to move laterally. Again, that happens in a matter of minutes. Exfiltration and encryption, mere seconds. Ransomware is deployed, letter is delivered, boom, game over. That was pretty fast. So now you might be thinking, well, we have a plan for recovery in such an event, and that's good, but we're not concerned about recovery here. It's not about workload recovery or accessibility. It's more about integrity and confidentiality of your data. And at this point, your data has already been compromised. It's too late, right? So what we want here is we want real-time machine speed detection and response for real-time machine speed cloud incidents, right? We have to be smarter and faster than the bad guys. So let me ask you this. If Batman drove a Tesla, pretty cool car, right, instead of the Batmobile, how easy of a time do you think he'd have catching the Joker? Right? I mean, I like Tesla, don't get me wrong. It's a cool car. It has some good features. It's nice. However, it doesn't have behavioral AI, right? Are you coming with me on this analogy? So I just assume Batmobile uses some kind of really cool behavioral AI. So we want the Batmobile of cloud security. Okay, enough of that analogy. The role of CWPP in cloud defense in depth. For a robust cybersecurity strategy, you really want a multi-layer cloud defense in-depth approach, all the way from AppSec on the left to your cloud workload protection platform on the right. So that's what we'll be focusing on. CWPP is your last line of defense, and it complements all other layers of the security stack, and it catches what the other guys don't. So it catches ransomware, crypto miners, malware loaded at runtime. And it provides forensic analysis. It provides persistent telemetry for your security team, what they need to do their job. So it has a dual purpose. Let's look at a couple of examples of runtime incidents. Here's an interesting stat for you, 146% increase in new Linux ransomware code variants. And now this is partially because of ransomware as a service. This has really lowered the barrier to access for less sophisticated adversaries, right? And some of you may remember dark radiation from last year. And the reason I bring this one up is it focused on Linux and Docker containers. And this is something that it was very difficult to detect because it was written entirely in Bash. Sentinel-1 was able to detect it instantly and protected all of our customers. Ransomware is second only to crypto mining. Let's talk a little bit about crypto mining. As you know, it's very computationally intensive. And so adversaries have a choice. They can either build their own server farm or they can siphon compute cycles off of your infrastructure, right? They get to keep the crypto, you pay the bill. Good deal for them, not so much for you. So adversaries are programmatically going around and knocking on doors to see who left their cloud house open. And once they find one, they gain access, they quietly drop their mining rig, rinse and repeat. So again, this is just another way of illustrating the real need for real-time detection and response, machine speed detection and response. So let's look at two different types of AI that we use for machine speed detection and response. The first being static AI. This is inspecting the files themselves. It's looking at how they're packed, how they're encoded and signed. It's looking for characteristics that may be indicative of some sort of malintent. And what it does is this is used after an executable is run, so it's preventative. It prevents rogue processes. It gives sort of a structure to the data. It is typically hard-coded from sources that don't change or they don't change very frequently. So this is a type of machine learning algorithm that separates the good from the bad. So it's unsupervised learning that doesn't require any feature labeling. And then we have behavioral AI. Now, this is a little bit different. This is looking at process monitoring. So it's looking at for unexpected behavior within a certain context in real time. So we're adding the element of time here. And what it's doing is it's linking events. It's saying, if A and then B and then C, then this may be suspicious. So for example, it might be suspicious to see the Notepad executable trying to initiate an RDP session, or to see mass encryption of a large number of files in a short period of time, right? But the thing is, we can't hard code every single possible scenario that might lead to a breach. That's why we have behavioral AI. So it learns over time how programs behave, how they're supposed to behave, and again, it separates the good from the bad. It improves. The more it observes, the more it learns. CWPP delivers high signal-to-noise ratio forensic details. What do we mean by that? Well, essentially, we're using AI to suppress noise and extract a clear signal. If you're drowning in alerts, how do you get a clear signal, right? So we're taking trillions of pieces of data, endpoint, email, network, cloud, identity, just to name a few. We have our native data sources, and then we have dozens of open integration, and we're pulling all of this data into the same platform. So all those trillions of pieces of raw data get boiled down into millions of enriched storylines. Remember those events we talked about? This connected to this, connected to this. Every single event is being tracked in real time in that cloud workload. So you have millions of enriched storylines that are grouped by sets of behavior. And then from there, we want to know. So if I'm an analyst, I want to know which of these storylines do I need to care about, right? So we boil it down into just a handful of actionable incidents, right? So the net effect is we improve detection speed and efficacy, we reduce mean time to detect and respond, we reduce adversary dwell time. Okay, let's take a look at, this is actually dark radiation, the one that we talked about. We can see the storyline here on the left, and you can see where it was launched, and then it spawned replicas, and then it spread laterally at machine speed. Now you see here that within 1 second of initiation, Sentinel-1's behavioral AI caught this, it stopped it in its tracks, it assembled all of the forensic details, it correlated all of the telemetry automatically, and it mapped all of the events to the MITRE ATT&CK framework. And all of that data is saved per the customer's data retention policy. So if this agent were set to protect mode, this would automatically be killed per policy. And so that's why none of our customers were affected by dark radiation. It is the Batmobile of cloud security. Okay. Singularity Cloud secures physical servers, virtual machines, Kubernetes containers, with the outcome of runtime security for workloads in AWS and data centers, cloud-first architecture with no kernel dependency hassles. It's easy on the DevOps team. It's easy to deploy, to manage, to update. It's one security umbrella for cloud endpoints. That's one console, one platform, not two, not four, one. Hence the namesake, Singularity, right? One click or autonomous cybersecurity. So as you saw in that last slide, that happened autonomously without human intervention. We do offer something called one-click rollback. So if the agent were set to detect only, I would have the option to, with one single click, roll it back to the pre-attack state. Coverage for many OSs, including Amazon Linux 2022. And because of our strategic partnership with AWS, we provide visibility and protection for workloads in AWS with multi-OS workload coverage, scale, and reliability, a very simple, easy procurement process. We transact through the AWS marketplace, and we do offer an AWS enterprise discount program, so please ask about our EDP. Support for FedRAMP moderate workloads in AWS GovCloud. Oops. I spoiled my final slide. Okay, we talked about a lot here today. So I just want to give you 4 key takeaways for you to walk away with. Let's just boil this down. And the first is that CWPP stops what others might not. And that includes ransomware, crypto miners, and runtime loaded malware. AI-driven EDR for ECS, Amazon EKS, and EC2. Persistent forensic detail. We collect the forensic details that the security team needs to do their job. And we offer better security, a more productive, and more importantly, a happier, much less stressed security team. So to learn more, you can visit our website, of course, and you can also scan this QR code, and that will give you a curated list of content. And our booth, I hope you visit us, is at 3543, so stop by, come chat with us. We're here all week. Thank you so much for listening. Have a great rest of your evening. Thank you very much.